everybody. Great to be here. So I'm Sarah Williams with Minus Materials. So I'm the CEO and co-founder of Minus Materials, and I'm super excited to be here today talking about our anchor project with the Four Corners Carbon Removal Coalition, as well as our multiplier campaign. So Minus Materials, we grow biorenewable carbon negative minerals using microalgae, specifically limestone. So Portland cement production, as you guys know, is responsible for about 8% of global CO2 emissions, and the principal feedstock material is limestone. So what we do is we grow a more sustainable biorenewable carbon negative version of that feedstock mineral. So to introduce our team, I'm Sarah, I'm the CEO. I have two co-founders. My co-founders are Dr. Will Shrubar and Danielle Beatty. We are all spun out of the University of Colorado Boulder. Will is actually a tenured professor at CU Boulder. We also have Dr. Nilanjana Mazumdar on board, who is a phycologist with specific expertise in scaling up algae cultures. So going to be very key to our effort here to create a regenerative limestone quarry pilot in Boulder. And we also have a couple rockstar scientific advisors. We have Dr. Mike Garnieri from the National Renewable Energy Lab and Dr. Caterina Alves de Souza from the University of North Carolina, Wilmington. So just to get down to the crux of our project and what we're trying to do, we're essentially reimagining the way that we source raw materials to make Portland cement. So for about at least 6,000 years now, we've been quarrying in much the same way, in that we go and we blast large sections of rock, and then we dig them up and we crush to a very fine powder. And in the case of Portland cement, that fine powder is then fed through the kiln where it's calcined, and a lot more CO2 is released in that process. So at Minus Materials, we are building regenerative limestone quarries where we're growing a carbon negative limestone product with calcifying microalgae. And what this does is it enables non-renewable geological limestone to remain undisturbed in geological formations, therefore continuing to store carbon. Yeah, so why biorenewable limestone? So limestone quarrying is a very controversial practice across the country and the world. We had quite a lot of news in our local community of Boulder over the past couple of years in limestone permitting for a major cement plant. And there's multiple situations across the country of cement plants that are set up to continue their given production volumes, but they are having trouble getting their permits renewed, often for good reason, because there have been violations or because of pushback from local communities that are unhappy about not only the carbon impact, but the impact to land use patterns, as well as impact in biodiversity of local communities. As when you're going through and quarrying land, you're really destroying a lot of that stuff. So we grow this limestone. Our limestone can store about 44% of CO2 by mass in a durable mineral form. And another key benefit is that we have this major CO2 benefit. We're obviously removing carbon dioxide removal technology, but we also reduce reliance on quarrying, which has a lot of benefits for biodiversity as well as land preservation. So some key facts about this specific pilot project. We are doing a rather small scale, but super impactful demonstration. We hope we're scaling up to about 1,250 liters. Continuous cultivation over a couple of months will yield us close to 1 ton of limestone. And then the resulting limestone will be used as a filler in Portland limestone cement concrete. Portland limestone cement is super popular nowadays, where you can replace about 15% of clinker content with limestone, which gives you some pretty significant CO2 reductions. And in the case that our limestone is added as the limestone component, there's further CO2 reduction since we're starting with a carbon negative filler material. And those numbers are so as the cells are growing through photosynthesis, they sequester about 1.8 kilograms of CO2 per kilogram of organic biomass through just the photosynthesis. And then in terms of the mineralization reaction, where they make limestone, they sequester about 0.4 kilograms of CO2 per kilogram of mineral limestone produced. And then finally, to announce our multiplier effort, we have simple requirements for feedstocks, but in order to scale the way that we want to supply limestone to the global cement industry, we're currently consuming over 6 gigatons of limestone globally in order to manufacture the global budget of about 4.4 gigatons of Portland cement. The feedstocks we need are saltwater brine sources, CO2, preferably waste point source CO2 rich flue gases. We'd like to characterize and test with our system, as well as alkaline waste materials that we use as a buffer in our system to grow the microalgae. So we're looking for partners, and please contact me if you are aware of any industrial waste streams that fall into any of these three categories, so that we could explore opportunities for testing those materials and potential co-location opportunities. Thank you very much for your time.